Welcome to the NPTEL MOOCs course on Discrete Mathematics. I am Dr. Benny George and I am a faculty member at the Department of Computer Science and Engineering, IIT Guwahati. My colleague, Prof. Sajith Gopalan and I will be jointly teaching this course. The teaching assistants for this course will be Mr. Ranjit Senko, Mr. Manas Kumar Panda and Mr. Badri Prasad Nanda. They are all senior PhD students at our department. Let me tell you a few details about this course. The course is about mathematics. So discrete mathematics is a subject which you can treat as an introduction into mathematics. So the techniques used in mathematics are finitary. In the sense, proofs are objects which cannot be infinite. This should be covered in a page or in a book and so on. It cannot be an infinite object like, let us say, the set of real numbers. This might sound a bit casual at the beginning. One of the purposes of the course is to make you understand that these things can be made very precise. The notion of what is countable, the notion of what is uncountable, etc. are covered in the beginning of the course. So mathematics, you can think of it as a study of logical relationships between various mathematically constructed objects. There are different kinds of mathematical objects. Their constructions is typically by means of fixed algorithms or fixed procedures, and these procedures result usually in finite objects. And these finite objects could have relationships to other finite objects. How do we understand these relationships? That is the purpose of study of discrete mathematics. We study about these objects, we learn about these objects, and the methods that we learn about these objects can be generalized throughout mathematics. So in some sense, a discrete math course is a course which all undergraduate mathematicians, computer scientists, electrical engineers will find very useful in developing their subjects further or understanding or gaining better understanding of their chosen discipline. In this course, we will be teaching things which starting undergraduate students from any branch of engineering can follow. Even senior high school students will be able to appreciate most of the things that we cover. But there will be few things which are related to computer science. For example, there will be some algorithms discussed during the course. And certain methods will be explained by means of algorithms, and this might require a little more familiarity than, let us say, high school mathematics. But pretty much anybody who has a liking towards mathematics can understand most of the contents of this course. More details into what is covered in the course will be discussed by my colleague Professor Sajith.
I am Sajith Gopalan. I will briefly run through the topics that we shall cover in this course. We will have a module on mathematical logic. Mathematical logic studies the expressive power of the semantics of formal systems. It also studies the expressive power of the deductive apparatus of the formal systems and their correlations. Mathematical logic has close connections to metamathematics, the foundations of mathematics, and theoretical computer science. Computability theory, the theory of semantics of programming languages, program verification, automated theorem proving, and logic programming are some of the areas in computer science where logic is used. We will have a module on set theory as well. Set theory forms a subfield of mathematical logic. In set theory, we study collections of objects. Set theory forms a foundation system for much of mathematics. It has been argued, particularly by Russell and Whitehead, that all of classical mathematics can be embedded in set theory using first or second order logic. For example, properties of natural and real numbers can be derived within set theory. Therefore, set theory forms a foundation for discrete mathematics too. Data structures and algorithms, database management systems, formal languages, programming language semantics are some of the areas in computer science where set theory comes in handy. We have a module on number theory as well. Number theory primarily deals with the study of integers, particularly non-negative integers called natural numbers. In some high school textbooks, these are called whole numbers. One major application of number theory is cryptography. We will have a module on algebra as well. An algebraic structure on a set A is a collection of finitary operations on A. The set A with this structure is also called an algebra. Examples include groups, rings, fields, and lattices. It has many applications. Cryptography, coding theory, number theory, combinatorics, graph theory are all areas where algebra is used. We'll study graphs. Graphs are mathematical structures used to model pairwise relations between objects. A graph is made up of vertices and edges. Vertices are also called nodes or points, and edges are also called links or lines. An edge is a connection between two vertices. Applications of graphs abound in computer science. For example, communication networks, conflict resolution, to name just two. We will also have modules on recurrences and generating functions. Hope to see all of you in the course. Thank you.